Hello my dear students, in this video I would like to discuss milling machine, introduction of milling machine, principles of machining, types of milling machine and milling machine operations. So this is the milling machine. It's a versatile machine common to all machine shops, and compared to shaper and planer, this is very useful, and accuracy, metal removal rate, etc. are very high compared to shaper machine. And as it uses a multi-point cutting tool, the operation will be very fast, less energy is required, and whatever the shapes which can be obtained in shaper, we can generate here also. So milling is a metal cutting operation in which the excess materials from the workpiece is removed by rotating a multi-point cutting tool, and the tool is known as milling cutter. Here work is fed, so feed is given to the workpiece by moving the table. The milling cutter rotates at high speed and it removes the metal at very fast rate with the help of multi-point cutting tool. That means there are multiple cutting edges. Used for machining flat surfaces, contoured surfaces, and external and internal threads. As the workpiece moves against the cutting edges of the milling cutter, metal is removed in the form of chips. So the metal removal process principle is same as all other machining process. The machine surface is formed in one or more passes of the work. So to cover the entire surface, you have to give multiple passes. So by giving the either longitudinal feed or cross feed. The work to be machined is to be held on a vise. That is the work holding device. Vise is kept on the table. A rotary table, a three-jaw chuck, or an indexing head. All these can be used for holding the workpieces. In many applications, due to its higher production rate and accuracy, milling machine has even replaced shaper and slotting machine. So these are the some of the shapes which can be generated in a milling machines. So all these are the straight cut edges, but we can also produce the contours, the curvatures. Also we can produce different pockets of different shapes, especially if you use a CNC milling machine, can be used for all types of shapes. uh, for example, if you want to produce the mold of a die or mold, so normally it is having different cavities that is widely made by using milling machines. Milling methods, there are two basic types of milling. That's based on the direction of rotation and the direction of feed. Up milling or conventional milling, down milling or climb milling. Up milling, it is a conventional milling, that is metal is removed by the rotating cutter against the direction of the travel of the workpiece. So the feed is against the direction of rotation of the cutter. It needs stronger holding of the job because there's a chance of lifting of the work or job because both are in the opposite direction. So we need to hold the workpiece very firm. And chip thickness is minimum at the starting of the cut and maximum at the end of the cut. Disadvantage is a tendency to lift the work from the fixture and the surface finish is also comparatively low. So this picture shows the up milling or conventional milling. From this you can see this is the cutter, this is the cutter, the direction of rotation is clockwise direction, and this is the table feed which is opposite to the direction of, that is the velocity here, peripheral velocity of the cutter is in the opposite direction to the direction of the feed. And you can see here the depth of cut is minimum at the beginning and maximum at the end. Down milling or climbed milling. Here the metal is removed by the cutter rotating in the same direction of the travel of the workpiece. So both the direction of feed and the peripheral velocity of the rotating cutter are same. Here teeth cut downwards instead of upwards. So it is down milling. Chip thickness is maximum at the starting point and minimum at the end. And here less friction involved, better surface finish, less power is required. So this is better. So here the figure shows the climb milling. Here you can see the cutter is moving downwards. So the velocity, peripheral velocity of the cutter is in the same direction of the table feed, and the depth of cut is maximum at the beginning, and when it becomes the end of the cut, it becomes minimum. So here power consumption is comparatively less, the surface finish is better. So these are the two types of milling operations, up milling and down milling. Types of milling machines. So based on the applications, different types of milling machines are available. So we'll see what are the different types. Milling machine may be classified in several types, but the choice of any particular machine is determined based on the application or the size of the workpiece. According to the general design, the distinctive types of milling machines are column and knee type. Then second one is planer milling machine. The third one is fixed bed type milling machine. And the fourth one is the special types of milling machines. So we will discuss all these different types later. Before that, we have to see what are the principal parts of a basic machine. The base is the one of the important which to accommodate all other components. Then the columns which will carry the uh, tool head. The knee which will carry the table, and on the knee there is a saddle is there to move the knee, and the table is also there. And there is a spindle. On the spindle we are connecting the cutter by using the arbor. So these are the principal parts. So we'll see what are the different components and its functions. This is the column and knee type. You can see this is the column, that is actually the strong structure on which all the mechanism and the driver etc. are inside this column. And this is the spindle. This is the actually swiveling head. So we can swivel this head, and this is the spindle. At the end of the spindle you can see the milling cutter, and this is the table. This is the table is on the saddle is on the knee, and the workpiece is at the top of the table. So the knee we can move up and down. There is a guideway on the on this face of the column. There is a guideway, and we can move the knee by rotating the screw. There is a screw is here. So the knee is on the connected with this vertical screw. So by rotating that screw, we can move or we can lift up and down the knee. It is the most commonly used milling machine. This column and knee type is very strong, robust, and it is commonly used. it is very rigid. The table is mounted on the knee. The knee is actually it is a cantilever beam, uh, which is uh, which is one end is supported and the other end is also supported by using a screw, but it can be moved. The knee is vertically adjustable on the column so that the table can be moved up and down. So the vertical feed can be given by moving the knee. The classification of the column and knee type. There are subdivisions. So the different types of column and knee type machines are hand milling machine. It is by using a manual machine. It's very small one. It is not normally used for metal cutting. Then the horizontal milling machine. Then universal milling machine, vertical milling machine. So column and knee type, there are mainly three types: horizontal, vertical, and universal. That is based on the tool head. These machines are classified. So in the horizontal milling machine, the tool is in the horizontal axis. It is rotating in the horizontal axis. The universal milling machine, we can swivel the tool head. The vertical milling machine, the tool axis is vertical. The horizontal milling machine has a spindle that is parallel to the shop floor or the bed of the or the table of the machine. The overarm supports the arbor, which holds the milling cutter. So there is an arbor, and the arbor is supported by an overarm. It is a cantilever beam, and in the arbor we can insert the cutter, and the arbor rotates when the spindle rotates. On the horizontal mill, the arbor is the component that rotates the milling cutter. So here you can see the figure of a horizontal milling machine. So this is the side view and this is the front view. So in the side view you can see this is the overarm, this is the arbor, and this is the milling cutter. So arbor in the milling cutter is inserted in the arbor, and by using spacers and a nut it is firmly held in this arbor. So the arbor is rotated by the spindle here inside this machine, and all driving mechanism is here inside the column. And when it is rotated, you can see the table here. On the table there is a vise for holding the workpiece, and this table is having 3 degrees of freedom. That you have to understand. 3 degrees of freedom are available. That means the table can move in the cross direction, that is towards the machine, towards the column, and the table can also move in the left and right direction, that is the horizontal feed, that is actually longitudinal feed. So the table can move longitudinally, also the table can move up and down. So 3 degrees of freedom are available for the table, and you cannot move this arbor. So arbor is stationary, that means you cannot change the axis of the arbor. So the tool will be rotating in the same place. We don't have any mechanism to move the tool, so only the workpiece will be moving to get the different shapes of the workpiece. So this is the actual photo of a horizontal milling machine. Now we'll see the arbor. Arbor is one of the important component or part of a milling machine. You can see this end is actually uh, connecting with the spindle by using a shank taper. And here this is the spacer. These are the spacers, and this is the milling cutter. So milling cutter is inserted by removing these spacers. First of all, we had to unbolt this one. So there is a nut is there, just loosen that nut and take out all the spacers and insert the milling cutter. After inserting the milling cutter, again you can insert the spacers, and finally you can tighten this nut so that there will not be any movement for this milling cutter. So when the arbor rotates, milling cutter also will rotate. So vertical milling machine, the spindle is vertical or perpendicular to the work table. So it is perpendicular, just like a drilling machine. It has all the movements of the table for proper setting and feeding. So the table movement is same, similar to the horizontal type milling machine. Spindle head may be swiveled at an angle. So that's one of the speciality. The head of the spindle can swivel, but in the horizontal milling machine, the head is stationary. In some machines, spindle can also be adjusted up or down related to the work, and it is adapted for machining grooves, slots, and flat surfaces. So this is the figure shows the vertical milling machine. So here, just like a drilling machine, you can see here this is the tool head, and this is the spindle and chuck, and on the chuck you can have the milling cutter. So this is the vise, and we can keep the workpiece here, and this is the table. The table is on the knee is on the vertical screw, and this is the board. Now we'll see the differences between horizontal and vertical milling machine. In the horizontal, spindle is horizontal and parallel to the workpiece, but in the vertical, it is vertical and perpendicular. Cutter cannot be moved up and down. Here, cutter can be moved. The cutter is mounted on the arbor. Here, cutter is directly mounted on the spindle. Spindle cannot be tilted. Here, spindle can be tilted. Okay. Now, the third type of column-native drill milling machine is universal milling machine. Here, the main difference is from the plain horizontal machine is addition of a table which can swivel. Housing permits table to swivel 45 degree in either direction of the horizontal plane. So here, this is the table. This table can move. We can swivel this table in the inclined position like this or here also. So the table can move in the it can swivel housing uh, in the horizontal plane. So this is the horizontal plane. So in the horizontal plane, the you can turn or you can swivel the table. So up to 45 degree. So for sometimes it is required for machining inclined surfaces. Then the second type of milling machine is fixed bed type milling machine. It's comparatively, it's very large, heavy. It's used for large or heavy duty, and table is directly mounted on the fixed bed. No provision is provided for cross or vertical adjustment of the table. So the table is actually only having only one direction, 1 degree of freedom. The cutter mounted on the spindle head, and it can be moved vertically on the column, and the spindle may be adjusted. So here actually the spindle tool head can move horizontally, but the degree of freedom for the table is only one. So there are three types: simplex, duplex, and duplex. So this is the model of the fixed bed milling machine. Now planar milling machine, this already we have discussed while discussing the planar machine. It looks like a double column planar machine. Only the difference is here the tool head consists of a spindle. So instead of a single point cutting tool, we are using a milling cutter here. So the milling cutter can be rotated in the milling head, the tool head, and all other aspects like the movement of the bed, etc., are similar to the planing machine. Then the special types of milling machines are designed for individual milling operations. That is based on the requirements and designs are there available. Just like tracer mills, you can also call as a duplicators, either tracer or duplicates. If it is used for a two-dimensional means tracer, then it is tracer machine. If it is for making a three-dimensional curvature, for example, if you want to make a contour, reproduce a contour or a regular part geometry, just make a template and move the tracer. So this machine consists of a tracer. So just to move the tracer over the template, and the same tracing will be taken by the tool, so that you will be getting the same shape on the workpiece. It's just like a copy machine. Then this is very important. CNC milling machine is widely used nowadays. Now manual machines are very less, so CNC milling machine is very widely used for getting, for generating, for machining any type of shape. And by using programs, you can do the coding, and based on the code, the tool head moves, or that both the tool head and as well as the table is having 3 degrees of freedom. Everything will be automatically moved, and finally you will be getting the required shape. Milling operations. So these are the some of the milling operations: plain or slab milling, face milling, end milling, side milling, slot milling, angular milling, form milling, straddle milling. So these milling operations are different milling operations for getting different surfaces, and here we are using different designs of cutters. So the profile of the cutter is different. That is the major difference. And some more machining operations are slitting or saw milling, gear cutting, keyway milling, string milling, profile milling, thread milling, helical milling, and cam milling. We'll see this one by one. So this figure shows a plane or slab milling. So the plane milling, the cutting edges are on the periphery of the cutter. So this type of cutter is can be only used for planing slabs. So for surface, flat, for generating flat surfaces, and the cutting action is by the cutting edges on the periphery of the milling cutter. So here this cutter can be used on a horizontal machine. So we can't use this cutter in a vertical head machine because the cutting surface is periphery of the cutter. So it has to be rotated in the horizontal axis. Then only cutting action will. So this is mainly used for generating, for creating, for machining flat surfaces. Now we see the face milling. So face milling is entirely different. Here the cutting action is because of the face of the milling cutter, and this design is also different, and this is used in the vertical milling machine. We cannot use this in a horizontal milling machine. This is also used for generating flat surfaces. So manufacturing of this flat surfaces is shown in this figure. Here what we have to do is we have to rotate the milling cutter at a high speed on a spindle in a vertical milling machine, and while it is rotating, just to move the table in the different directions, either in the x direction or y direction, so that the entire surface will be means the machining will be continued or extended to the entire surface. So the cutting action is because of the cutting edges. You can see here cutting edge, and because when the cutting edge touches the workpiece, because of the shearing action, the metal will be removed. So one after the, as it is rotating, so the cutting edges will be changing instantaneously. So now this edge is cutting, so next time the next this will be cutting like that, the cutting edges will be changing in time. So this is another milling operation. This is known as end milling operation. End milling. So end milling cutters are used. Here also this is done in a vertical milling machine. Vertical milling machines. This operation is performed for producing flat surfaces or key slots, grooves, or finishing the edges of the workpiece. So here the milling cutter is smaller diameter, just like a drill bit, and it is now widely used for making pockets and keyways, slots, etc. This is side milling. This is used in a horizontal milling machine because the cutting is performed because of the periphery of the milling cutter. By using the periphery of the milling cutter, this is used for producing flat surfaces, slots, grooves, or finishing the edges of the workpiece. Slot milling. Here you can see the this is also just like a peripheral milling. At the same time, this is the side milling is also done. That means here the tooth of the milling cutter is it can cut by using the periphery of the cutter or the surface of the cutter, and also by using the face of the milling cutter. So both actions will be here, so that we can simultaneously machine the T slots. That is operation of producing slots like T slots, spring slots, etc. It is an N milling cutter with a T slot cutter. So first of all, we had to produce this groove. So only after cutting this groove we can use this type of cutters to produce the T slots. So first main groove has to be machined by using an end milling cutter. So here you can see how it is produced. So this is the end milling cutter. This is the end milling cutter. So first of all we had to produce this. First cut is slotting this one. And the second cut is actually by using a large diameter cutter, and that cutter you can start from the one end, and while machining just give the feed to the workpiece so that the cutter will go inside. The cutter will go inside to the workpiece, and you can generate a T slot throughout the length. So the feed is given to the table. Angular milling. This is for getting an angular shape. So V cut. Operation of producing all types of angular cuts. For example, V notches. The cutter is a double angle cutter. So you can see the cutter is having double angle. That means it is a conical shape, and it is used with a horizontal milling machine. And form milling is actually for reproducing or generating the same shape of the milling cutter on the workpiece. Operation of producing all types of angular cuts like V notches and grooves, serrations, and angular surface. So any shape we can generate based on the shape of the milling cutter. That is actually just like a forming operation, but it is not a forming, it is actually machining operations. But as the shape of the cutter can be uh, can be reproduced on the workpiece, and this also used a horizontal milling machine. See, this is another type of form milling. So you can see this the shape because the profile of the milling cutter is different, just opposite to the previous one. So any shape can be produced. This is also the horizontal milling machine. So this is straddle milling machine. It's having multiple cutters. For example, two cutters are there. So both will be connected to the same spindle or the arbor, and this is also horizontal milling machine. And here the cutting is with both the periphery as well as the face. So both surface, that means the horizontal surface and vertical surface, are simultaneously machined on both sides. So this is used for operation of machining two parallel surfaces simultaneously on a workpiece. So this is another example. So here there are three cutters together with on a spindle. So for getting that shape, that means the advantage is the time. You can save the time. So by single operations, two or by single operations, three surfaces are generated simultaneously. So that is the advantage. So profile milling. Profile milling, actually it is machining the outside periphery of the flat surface. It's a conventional end mill is used. So end mill can be used for profile milling. So profile milling means the profile of the workpiece can be generated or machined. That is by circulating the cutting tool on the outer surface of the workpiece. So normally the end mill is used. This vertical milling machine we can do this operation. Pocket milling is also similar, but it is used for machining a pocket on a workpiece that is inside. This is also end mill is used, but the shape obtained is something different. That is why it is known as pocket milling. The operation is same. So a different cutter is used here. So this type of milling cutters are widely used for manufacturing mold or die, where we need a lot of cavities like pockets. So also we can use this cutting tool in the CNC milling machine. So how this pocket is generated by giving different feeds on the table. That means X Y movement can be possible on table, and by moving the table and giving a vertical feed either on the table or on the cutting tool, you can give the depth of cut and trace the path. Trace the path. Sometimes one or two or three passes is required for creating this cavity. This is a surface contouring operations. Here, the major difference is this is done on the outer surface for creating a convex surface for any contour. It's a ball nose cutter is used, and it is fed back and forth, so it is moving back and forth several times along the curvilinear path at close intervals to create a three-dimensional surface. So for example, if you want to produce a can, this milling cutter can be used for producing different profile can. So these are all about the milling machine, milling operations, parts, functions, and milling cutter. Thank you.